uh, recap. Okay, fine, I'll give you a recap. Okay, this is what we have done in vector. See guys, in general terms, a vector for us is a directed line segment, right? Okay, it has certain length, so this arrow is a vector for us, this is a vector for us, this is a vector for us, okay, this is also a vector for us. Okay, all these are line segments of different lengths. We say they have different magnitude. Okay, instead of length, right, length of a vector means magnitude, right? That is what I told you. All of them, they can be named differently also. Okay, we can call it A vector, this I can call it B vector, C vector, D vector, like that. And I told you, right, this is called the tip of the vector and this is called tail of the vector. Okay, this part here. So all the vectors, they have tip and tail, and you can give names to the tip and tail also, guys. Okay, see, I can call this as A here, I can call it as B. These are not vectors, these are points. Okay, the tip is called B here, A is called tail here. So I can just write like this also. See, AB I can write, which is a line segment, and then I can give an arrow. That means this line segment is directed from where to where? A to B. Okay,
B.
and yeah, this is, in short, we can also call it what vector directly? C vector. C is not tip, C is not tail. Okay, C is directly the whole vector, right? That's how we can name it. Okay, you can also use small letters. I have not seen in this book, I'm using Accelerator till now, I have not seen small letters, but somewhere maybe you may just be able to use them also as well. Okay, then I told you like this, right? See, I have introduced to you how to write a vector. Okay, see, suppose I have this vector. We'll start with the previous day's problem a bit. Okay, then we can proceed to our new topic today. Okay, see guys, so we have this vector, let's call it A vector. And I told you, right, a vector is actually, right, used in physics, and a vector is something which has magnitude plus direction. Okay, and I gave you so many examples. Okay, even you have helped me to fill up that difference between scalars and vectors. No, you told me scalars are only with magnitudes, vectors are with magnitude and direction. Okay, so can you just fill up it again very quickly? Vectors, quantities, vectors, quantities, which are vectors? Force, yes, force is direction, force is magnitude. Momentum, displacement, yes. Acceleration, yes, acceleration is a vector. Velocity is a vector. Momentum, P, no, P is a vector then. Yes.
So intensity.
Intensity is not a vector, right? Intensity is scalar, no? Pressure is a scalar vector. I think I saw it as
Scalar.
Pressure is scalar. Okay, then
Sir, weight.
weight is a vector. Yes, weight is a vector.
Sir, type.
Time is not a vector. Time is scalar.
Sir, mass is scalar, right?
Mass is scalar. Yes, mass is scalar.
So
Torque is a vector. Yes, torque is a vector. Angular displacement, if you have heard about it, is also a vector. And yeah, and of course we have many of them, right? Okay, which are vectors. Okay, and the best part is, I told you this. See guys, any of these vector quantities, right, I can represent with an arrow, right? This one. Okay, we can do that. Okay, example, I can tell you this is a force vector. This is 5 newtons of force pointing in the east direction. I can tell you that. Because of this, right, I can say force has magnitude and force has direction. I can also tell you that, yeah, this one. Okay, see, I can tell you that this is also a vector. Let's say it is a velocity vector, 5 meter per second in the east direction, right? It's pointing towards the east and it has a magnitude of 5. Okay, I can show you another velocity which is a much greater velocity. Okay, I can call it 15 meters per second in the east direction, right? So see, the moment I talk about larger velocities, I have to draw longer arrows. No, that is how we represent a vector. Okay, so very quickly I'll ask you one simple idea. Okay, if I tell you that if this is a vector, right, representing 10 newtons of force in the east direction, right, what will you call this, guys? This is also a force vector, the second one. Check this one. What will I call it? Is it 10 newtons or less than 10 newtons?
Less than 10 newtons.
Less than 10 newtons. If it is exactly half of that, I can say that it is representing how many newtons? Half the size, right? 5 newtons, pointing in east direction, west, whatever you like to call it. Okay, so that's how vectors they work. No, we can represent them by arrows and we can study them now. Okay, that is what we are actually dealing with. Okay guys, so see, in the process I told you, okay, how to write a vector. Okay. Oh, Andrea has joined now. Okay, fine. See, okay, so in the process, Andrea, you have not missed anything right now. We're just discussing from the previous day's topics. Okay, so in the process, yeah, I told you how to talk about a vector. Okay, and how to write, that is has to be clear today. Okay, this part. Say, if I tell you this is a vector A, I told you, right, it must have magnitude, which represents the size or the length of this vector, and then it should have direction, so the information of direction also should be there. Okay, so how do we write this vector? Let me make it clear. See guys, vector A is equal to, I told you it should have magnitude and direction. For magnitude, how do we write, guys? Anybody who knows? How do we write magnitude of the vector of A, suppose?
Sir, modulus A bar.
Yeah, we write A bar. Okay, we write A bar and we give this symbol here which stands for mod, right? We call it modulus. Okay, so this represents what? This represents only magnitude. Okay, this does not represent direction. This part only represents magnitude of the vector. That's how we write it. Okay, don't worry, things will become more clear. Okay, how do we write direction, guys? Who can tell me? How do we write direction? A hat, very good. Okay, we write A hat or A cap. Okay, cap, we can call it A hat or A cap. We can use any one of them. Okay, so this is a name, by the way, right? This A hat or A cap has a name. What is this called, guys?
It's a unit vector.
It's a unit vector. Very good. We call it a unit vector. And the job of a unit vector is to give direction. Okay, but you're just not going to call it unit vector. We are going to call it unit vector in the direction. In the direction of which vector? A vector.
Of A bar.
A bar. Okay, so this is how we write. Okay, so let me just show you again very quickly. If I write a vector A, it has a magnitude. I can simply write A also, by the way. Okay, I can do that, and I can write A hat, or I can also write A vector, then like this, and then I can write like that. Okay, again, meaning is same. This represents magnitude of the vector, this represents magnitude of the vector, this represents direction of the vector, and we call it unit vector. Okay, let me just again show you how to talk about unit vector again. Okay, very quickly I'll do that so that you understand what is going on. Okay, suppose I tell you this is a vector, and the size of this vector, let me show you, 1 2 3 4 5 6 and 7 units. Okay, so suppose I tell you A vector is a vector which is 7 units in size. Okay, 7 is the length, right? That's the magnitude. Okay, then I tell you direction, suppose east. Okay, just like that, I'm writing east right now. Okay, so if I ask you now, what is the magnitude of A vector? What is your answer, guys? What is the magnitude of A? That means I'm only asking you size. Okay, your answer is 7 units. You are not going to tell me east. Okay, you are not going to tell me the direction. It is obviously there, but you are not going to tell me because I'm not asking you that. Okay, I'm asking only the magnitude. If I'm asking you this, only the magnitude. Okay, then what about the unit vector, right? Now you should also see where is your A hat. Okay, I will show you that. See, unit vector by the name itself, right? Unit vector means it is a vector. It should point in the direction of which vector, guys? It is a vector. It should point in the direction of A vector, and the size should be how long? How long it should be?
1 unit.
One unit. Yes, I'm going to show you that. Okay, very quickly I'll do that. Okay, see this one, the green arrow. If you can see, I'm drawing it, and I'm drawing it of only one length, right? So this is called A hat. That is your A hat, and this entire arrow from here to here, right? That is your A vector. Okay, are you clear, guys? What is unit vector?
Yes, sir.
Yes,
So this is clear, no? Bajrihun is clear.
Yes, sir.
Okay. So I'll show you another way, okay, to write unit vector from here. See, I can tell you that A vector is equal to magnitude and unit vector. From here I can write unit vector is equal to, take the vector, divide by what? Divide by the magnitude, no? That is the definition actually, right? That is what I think I've given you last time. This is the definition of your unit vector, no? Take the vector, divide by its magnitude. You should be getting a unit vector. Okay, don't worry, later maybe we'll practice it more. Okay, so many questions will be there and things will be fine. Okay, now I just want to show you very quickly about this also. Okay, check. We've used these axes, no? We've used this as positive x-axis, we have used this as positive y-axis, and this is your positive z-axis. Okay, out of the screen, no? Positive z. Okay, then of course this we know, this is negative x-axis, this is negative y-axis, this is negative z-axis, and obviously this is the center or the origin we call it. And let's take one unit length, no? 1 unit, 2 units, 3 unit, 4 unit, 5 units, 1 unit, 2 unit, 3 4 5. These are actual space. Okay, 1 2 3 4 5 actual real space. Okay, this one, this is not a graph. Okay, don't think it's a graph. No, this is not x and y graph. Okay, these are x direction, positive x, negative x. Okay, not graph at all. Okay, then here also we have positive 1 2 3 4 5 6, right? So I have also introduced to you about unit vectors in these very specific directions. Okay, if you remember them, it's very nice. Please check. Okay, see, the unit vector in the positive x direction, right? What is that called, guys?
I cap.
I cap. So let me show you, okay. If there is a vector pointing in the positive x direction, okay, and has only one unit as the size of 1 unit, right, then obviously I have to call it unit vector, and this vector has a name, we call it I hat. So I think everybody's clear with I hat, right? Check guys.
Yes, sir.
Okay.
Yes, sir. Yes, sir.
A vector which is 1 unit long and pointing in the positive x direction, we're simply going to call it I hat, okay. Similarly, a vector in the y direction, I'm going to call it what? See, look at this, okay, green arrow again, from here to here, right, pointing in the positive y direction and 1 unit long, I'm going to call it j hat.
J cap.
J cap, okay, j hat.
J caps
Done.
for the y axis.
Yes, okay, and then for the positive z, this one, right, 1 unit long, what is this called, guys?
K.
K hat.
K
hat.
K cap or K hat, okay, yeah, that is what we have now. And we also know, right, on the negative x-axis, if I call that other one as plus I cap, this will be called minus I cap.
Minus.
Similarly, on the negative j, I'm going to call it minus j, minus j hat, okay. And the negative z-axis, right, the 1 unit long vector, I'm going to call it unit vector as minus k hat, okay. So these were the different unit vectors, and I'll tell you how do we use it, okay. Simply, if I tell you that I'm writing 5 I hat, what does it mean, guys? Just think and tell me, is it a vector or not? Is it a vector?
Yes, sir.
Yes, sir.
Is it a vector? Yes, because you can see it has a magnitude and it also has direction.
Direction.
What is the
Direction.
magnitude? What is the magnitude?
5 units.
5 units, very good. 5 units. It can be 5 newtons, it can be 5 meters per second, it can be 5 meters per second square, right? Magnitude is 5 units, okay. What is the direction?
Towards positive x.
Positive x-axis, very good, because you know, right, because I cap is there, that means it is definitely pointing in positive x direction, okay. Yes, I'll quickly show you, okay. See, so I showed you this again, yeah, okay. So I'll quickly show you, this is your positive x-axis. I told you 1 unit long vector, what is this called, guys? I told you this is called I cap, okay. And then finally, if I draw 1 I cap, 2 I cap, 3, 4, 5 I cap, this was 5 units long, okay. So that is what is your vector that I have written in front, okay. That is 5 I cap. I hope all of you understand the concept, right? So this is your
Yes,
I cap,
sir.
and that green arrow
Yes,
is
sir.
5 I cap, okay. I think till now everybody is fine. I think we can proceed, okay. Then yes, okay, I think we are okay to proceed, okay. And by the way, I think you also remember this one, right? If I write this as a bar, right, there are different types of vectors, if you remember, we have discussed, right? What is the first one? Equal vectors, I think, no? Anybody remembers equal vectors?
Yes, sir.
When are two vectors going to be called equal, guys? If
They have the same magnitude.
They have the same magnitude.
yes, if magnitude of a, if magnitude of
Yeah,
a
in the same
is
direction, sir.
magnitude of b is same, then direction of a is same as direction of b. Yes, then we call them equal vectors. Let me show you very quickly. I think I don't have to do this. Okay, you guys have already watched the video and attended also. Then this one, okay. Then this one. Sarnadeep is asking me recording, right? Recording, I will tell you, okay, whether I have recorded or not at last, okay? Because you cannot, you want to go, Sarnadeep? No, right? You have to revise, then I'll send you, okay? If I record, and every time if I have this habit of recording and sending, now I told you, no, the students, they become lazy, okay, to attend on that particular day, okay? Sarnadeep cannot hear anything. Why? Hello? Sarnadeep? Others can hear me. Sarnadeep, try to talk. Hello, Sarnadeep? Okay, Sarnadeep is having problem. Okay, see. Okay, so see. So these two vectors, right, we call them what vectors? Equal vectors, right? Because they are pointing in the same direction. So the unit vector is in same direction and they have same size, no? So we call them equal vectors, okay? So at this point, I don't want to talk about more than this, but I just want to ask you everyone, okay? Do you know what is zero vector, guys? What is a zero vector? Very important, we need it.
So both are
Magnitude
zero.
A vector whose
zero and arbitrary direction.
vector with magnitude 0 and arbitrary, very good, okay, arbitrary direction. Arbitrary direction means what? It's just pointing in any direction we don't know, okay, and zero vector looks like this actually, see. It's not even a vector, okay, it looks like that, it doesn't have any length, no. So that is what is called as a zero vector, okay. Property of zero vector, I don't have to tell you much, but simply remember this, right? If I add zero vector to a vector A, what will I get?
Zero.
Zero or a vector?
Vector A, sir.
Vector A. It's like you're not adding any vector, no? It's like that, right? So zero is just like you can treat like a number, okay? But actually it's not a number, it is a zero vector. That has to be clear. Okay, I think we can start with our next topic. Okay, so this is important. See, our next topic. Okay, addition of vectors. Addition of vectors. I'll tell you why this topic is needed, then I will proceed. Okay, so this is our topic today. Okay, this is number 1. Let me write it down. Later I'll ask you, okay, when we revise what we did today. Okay, see, before I proceed to addition of vectors, let's go to some scalars first. How are scalars added? Okay, example of scalars I'll give you. Let's say time t1. Okay, time t1 is equal to, let's say, 10 seconds. Time t2 equals to 20 seconds. Okay, time t3 equals to 30 seconds. That's an example. Okay, let's say I did some work in 10 seconds and again some work in 20 seconds, again some work in 30 seconds, right? So what is the total time taken by me, guys, in doing all the 3 work? How much total time? 30 plus
60.
20 plus 60.
60.
Okay,
60 seconds.
so what did I do here? I added directly, right? I added this,
Yes, sir.
this and this. Okay,
Yes, sir.
yes, I'll show you another one. Okay, if I have a bucket, okay, okay, forget about bucket. Okay, if I take something which is 1 kg, put it in the bucket. Okay, 1 kg, then something which is 3 kg I'm putting in the bucket, and again something in that is of 5 kg. Okay, so how much is the total mass? Forget about the
9
9
kg.
9
kg.
kg, 9 kg. Okay, yeah. So you realize something. When I added this time, which is a scalar, when I added the mass, which is a scalar, obviously there is no direction. I don't have to think much about the direction. Okay, just come on, keep on adding, right? Keep on adding.
Yes, sir.
Okay,
Yes.
yeah. Okay, or as subtracting also, I'll show you how to subtract scalars. Okay, very easy. See, if I talk about, let's say you have an energy. Energy is a scalar, by the way. Okay, energy is a scalar, no? Yes, scalar. Even work. Okay, even work is what? Work is scalar. Okay, I'll give an example. See, okay, suppose I have an energy. Okay, I have energy about 100 joules, and then I tell you I have done a work. Okay, I've done a work of 30 joules, suppose. Now tell me, okay, is my energy still the same, or is going to reduce? It will reduce. Okay, I
Reduce,
have
sir.
100 joules of energy. Yeah, I have 100 joules of energy. I do 30 joules of work. My energy left will be how much?
60.
60 or 70?
70.
70. Okay, why I'm writing kg? 70 joules. Okay, in any of these cases, right, whether you add or subtract, okay, I was talking about scalars, and you know what, you don't have to think about direction at all. No point of talking about direction. Simply add like numbers. Okay, that is what we have done. Okay, simply add or subtract like normal numbers. That's what you do with scalars. Okay, but let me show you something now. Okay, see, imagine, okay, imagine this is a river. Okay, this is a river. Let me say this is the direction of water. Okay, flowing down. Okay, and the water is going down. You know, the water is going down at the speed of or velocity of 10 meters per second. I think this is clear, right? There's a speed of water. Are you clear? Or velocity actually?
Yes,
Okay.
Yes, sir.
Okay. This is clear, right? This is the direction. Okay, it has direction, right? See, the arrows are showing, no, what is the velocity of the water. I think this part is clear, right?
Yes, sir.
yes, sir.
Yes, sir.
Okay, this is clear. Okay, fine. Now let me take a boat. Okay, I don't know whether you have done this type of problems or not. Let me take a boat and let me throw the boat in this direction. Okay, that means the boat is trying to go in this direction. Okay, and the speed of the boat is, suppose I tell you that speed of the boat is, again, how much do I put? Okay, let me put 50 meters per second. Just an example. Okay, so this is the speed of the boat or velocity of the boat actually. Okay, the value is this much and it has a direction. You can see the arrow, right? Okay, so this is the direction of what? Of the boat. That's the direction of the boat.
Increase
Yes, and this is the direction, right? This is the direction of water.
water.
Okay, now think and tell me, okay, is the boat really going to move in this direction or not?
Sir, it will go, but with a slower speed.
It will go, right? It will go in that. Do you think it will go in that direction, guys? That's the question actually.
Yes, sir. It will
Yes, sir, it will go,
Yes,
but
sir.
with
No,
a very
no. The boat cannot go in that direction.
Towards the direction of the water.
Okay. Okay, I'll give you another example. Those who did not understand, okay, I'll give you another example. Okay, look at this. Okay, this is nothing right now, but let's say rainfall. Okay, rain falls vertically downwards, right?
Yes, sir.
This is the direction of rainfall. Okay, this is how rain droplets they fall. This is quite easy. Everybody understood this one, right? Okay,
Yes, sir.
imagine there's a wind in this direction. Okay, I'll show you. Wind, let's say, is in this direction. Okay, now you tell me, will the raindrops fall vertically down or they'll not fall vertically down?
So it will go towards the left side.
Yes,
It will go towards the left.
Like that, right? Do you agree on this, guys?
Yes,
Yes,
sir.
sir.
Okay.
Yes, sir.
Okay, so what is this? This is the direction of what?
So rain.
Rain.
Velocity. This is the direction of velocity of rain.
Rain.
What is this?
Direction of wind.
Direction of air.
Direction of wind. Okay, direction of wind. Very good. Direction of wind. Or actually, this is the direction of velocity of wind, right?
Yes, sir.
This
Yes,
is
sir.
this is direction of what? Direction of rain. Velocity of rain.
Velocity of rain.
Velocity of rain. Okay, direction velocity of rain. So what is this? What is this?
So resultant velocity of resultant direction of the velocity of rain.
Is it? This is. I can say this is the actual, or this is going to be the result of these two velocities. Can you understand? Result
Yes,
of
sir.
Yes, sir.
result of velocity of the wind and the velocity of the rain is what? The result will be the velocity of the rain will be in this direction. Do you understand this, guys?
Yes,
I'll speak. I'll tell you
Yes, sir.
something. Okay, I'll tell you something. It means, you know what? It means that the velocity of the wind is going to affect the velocity of what?
Rain.
Rain is going to affect, right? So that's why, no, the result in the, or the total velocity, or the resultant velocity, actually we call it, no, will be different. Okay, so do you realize what is happening here? When I add the velocity, which is a vector, with another velocity, we can do that. I'm trying to add here, actually. Okay, add this and this. Okay, you will see that the result is totally different. Okay, I'll give you another example very quickly, and then you think about it. Okay, yes, I'll give you another example, those who did not understand. Okay, see, this is a box. Okay, and this is a what? This is a platform. Okay, imagine. Okay, platform, I think you know. How do I tell you? We're looking from top. Okay, this is a box. We're looking from top. Okay, top. Then imagine I attach a rope here. I attach a rope here. Okay, I pull in this direction with a force of 50 newtons, and you also pull in this direction. Okay, with a force of how many newtons? 50 newtons. Okay, so how many forces are acting, guys? This is called F1, and what is this?
Two forces.
Two forces. Okay, now what do you think? The box is going to feel two force or single force?
So zero
Two
vector.
force.
Okay, let me change my question. Okay, my question is, will the box move in this direction, or will the box move in this direction? One
So
or
it will
two?
stay the same place.
Okay, let me ask you like this.
So it will move forward.
Forward. Okay, you said forward. Actually, you know what? The box is going to move in this direction, right?
Yes, sir.
Okay.
Yes,
Do you understand this scenario, guys? Check. If I pull here, the box will not go here. The box will not go here. The box will be in this path or not.
Yes, sir.
So what will I call it? I call it force, or I'll call it result of the two forces.
Resultant force.
Result of the two forces. That's why it has a name. We call it resultant. Okay, we call it what? Resultant. Okay, the result of any two vectors, right? Okay, we will call it resultant, or the value, right, after mixing up many vector quantities, right? The value that we get, no, we call it resultant. Okay, so resultant is used for not only force. You can have resultant velocity, you can have resultant displacement, you can have resultant what is that I said? Velocity, force, displacement. Okay, any vector quantity. Resultant momentum also you can have. Acceleration also you can have resultant. Okay, I'll give you one more example very quickly. Okay, think about this. See, look at this diagram. Okay, now you'll understand. See, let's say this is an object here at point O. Then let me draw like this. See, this is an arrow. Okay, so it's pointing, it's a vector right now, you can understand. Let's say it is 3 I cap. I think everybody understands 3 I cap, right?
Moving towards the x-axis.
Yes,
Yes,
moving
sir.
That's
across.
positive x-axis.
Yes, this is 3 I
It's a
cap.
positive x-axis.
Okay,
Yes,
okay.
right.
Let's give it a name. Let's call it A bar. Okay, this is everybody's clear, right? Check, all of you guys.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
sir.
Now check. Okay, check. I'm going to do something more. That means, you know what? I have gone from, okay, let me just not write it A vector. Let me just give tip and tail. Okay, this is O. This point is A. Let's say the vector name is OA now. Okay, OA. That is your 3 I cap. Then you know what? I'm going to say that no, that is not the only place I go. Okay, I also go in this direction. Check. Okay, I go in this direction. Then after that, Okay, I go to another point. Okay, let's call it point B. So that is where I have stopped. Okay, I hope you are clear with this, right?
Yes, sir.
Okay, so
Yes, sir.
how will I write it, guys? How will I write it?
So negative.
Negative.
So negative z-axis.
Okay, okay. What is this green arrow? Who can tell me what is this green arrow? How much? 1, 2, 3. 1, 2, 3. This green arrow is how many units, guys? Check.
3 units.
So 3
Is
units.
that
3 units in X, Y, or Z. X, Y, or Z. Y.
Why?
So Y. Y means
J.
J. No, that is the meaning of this. Yes.
Yes,
Because see, this is J cap. This is J cap. This is I cap. This is J cap. This is I cap. So you know how it's written, right? Now think. Okay, what is OA, guys? Let's be clear. Okay, what is OA? What is OA? Don't tell
So
me the
3
value.
I cap.
No. Don't tell me the value. What does OA represents?
Distance from O to A in the positive x-axis.
He started wrong. He said distance. No. What is OA, guys?
it's a velocity?
Velocity.
No. I said the object is going from O to which point?
A.
A. Then the object is going from A to where?
B.
B. Okay. I'm simply asking you what is OA? OA represents what? OA represents what?
Distance.
Distance or displacement?
Displacement.
Displacement.
So displacement.
Okay. But the object it has only one displacement, or it has another displacement?
Another displacement.
What is that?
Another
What is that?
from
What is
A
that
to B.
displacement? From A to B
A
is
to
another
B.
displacement. Yes or no, guys? This is again displacement is there, right? Displacement. Okay.
Yes, sir.
Displacement. Now you think and tell me. Okay. Is AO or OA, right? AB and OA, are this displacement? Yes, they are individual displacement going from A to B and O to A. But what about the result? What is the initial point, guys, in this entire motion? Who's the initial point?
O.
O.
So O.
O, right? Initial point. And who's the final point?
B.
B.
B. B is the final
point.
Final point.
B is the final point. Let's be clear with that. Okay. Okay. So I'm going to draw an arrow now and think about this. Okay. What is this vector, guys?
Total displacement.
O2 from O to A. From O to A, right? Oh, sorry. Not O to A, but from
So
what to
O
A?
to B.
O to B. Let's be clear. Okay. What is O to B? O to B represents a vector from initial point to final point. This is our displacement or resultant displacement.
Resultant.
So resultant displacement.
Resultant displacement. You will agree with me that it is a result of two individual displacements, right?
Yes, sir.
Okay. One displacement is this, and the other displacement is this. So when I add these two, then I get this displacement. I will have to call it resultant displacement. Okay. I hope so. Till now is clear, right, for all of you?
Sir.
Yes, sir.
Sir, what will be the direction of resultant displacement?
Very good question. Okay.
Minus Z.
No. Wait a minute. That's a very good question. Okay, but I will give you the answer. Okay. His question is a very nice question. Okay. Tell me, what is the displacement of the first one, OA? What is the direction?
Positive.
So positive X.
Positive X. Okay. What is the direction of AB?
Positive Y.
Positive Y.
Positive Y. Very good. Okay. Now you think and tell me. Do you all agree that OB is the resultant or not?
Yes, sir.
Yes, sir.
Okay. Now look at the diagram and tell me, what do you think? OB is
So-
acting. Wait. OB is acting in X or Y or both?
So both.
Both. Or in between, actually, right?
So negative z-axis.
No. That is not negative z-axis. Z-axis is not here at all in the problem. This arrow here represents a direction between what and what? Between the positive X direction and between the positive Y direction. In between. Can you understand?
Yes, sir.
So
Yes,
then it
sir.
will be positive XY.
Yes, in between positive XY. This is positive XY. Don't bring Z right now, okay? But wait a minute. Let me ask you just simple words, okay? Simple. You tell me, where is OA acting in positive X? Yes. Where is AB acting positive Y? Where is your resultant? It's like you're moving to the X also. It's like moving to the Y also, right? So where will be your resultant displacement, guys? Only in X or Y or both?
Both.
Both. Your resultant is both or not? Check.
In between.
In between, yeah, both. In between.
Both, sir.
Both X also, Y also. Can you agree? Can I ever say that no, it is only moving in X after this? No, right? Your position has changed towards the X direction. Your position has changed also towards which direction?
Y.
Y direction.
Right.
And that's why I'm going to say that you're moving in X also and you're moving in Y
Y
also.
also.
Now you must be thinking how to write. So let me just show you. Okay, check. See, okay. You will agree with me, right? That if I start from here and draw a vector like this, don't worry, we'll discuss the rule. Okay, then everything will be simple. I think I should go directly to the rule. Okay, so how to add vectors? Let me go directly. Okay, don't worry, till here you are doing fine, but you understood what I want to say, right? Okay, can I go to the rules, guys, directly? That is the best thing to do, I think, right now. Okay.
Yes, sir.
Okay, so I'm going to talk about how do we add vectors, addition of vectors.
Sir.
Yes, yes.
So in the first example about the boat
Yes.
would be moving in straight line.
That also is not actually, I should not tell you. Okay, actually the boat also, no, where is that? See, the boat also is going to take a curve like that actually, right? You understand, right? Because something is pushing it down, na? Right?
Yes,
Okay,
sir.
so exactly I will to tell you, if it starts from here and stops here, no, by taking a curve, then what the motion is this, okay, the path is this, but I can average it out and say that the velocity was in this direction, see, like that. Don't worry about this. Okay, right now I think it's not a good time. Okay, don't worry, let's go to addition of vectors. Okay, whoever asks me is a good question, but let's wait. Okay, please wait for me, huh? Okay, see, let's talk about addition of vectors. See, do you already realize that addition of vectors is not like addition of scalars, right? Okay, let me show you again.
So it's different.
It's different. Okay, imagine this is positive X, this is positive Y, this is negative Y. Okay, if I have a vector in this direction and I want to add with a vector in this direction, okay, vector A with vector B, where is vector A, guys? Tell me, in between what and what? Positive X and positive Y.
Positive Y.
Where is vector B?
Between positive Y and negative.
Yes, okay, yes,
No,
okay.
negative Y and
Positive
positive.
Y.
And
negative.
where will be the total of these two?
Positive X and negative.
So total of these two will be where? Somewhere here, in between. Can you understand? So direction is very important, right? See, you just cannot tell me, okay, that the total will be this. Okay, you have to mention the direction. No, okay, that is very important. Okay, in scalars it was very simple, just add or subtract, you got it. But here you have to tell me, right, where will be the resultant, where will be the result. Okay, that is why, okay, we need to follow some rules. Okay, so please check, you'll get me, just give me time. So see, addition of vectors, there are three laws I can talk about. The first one is triangle law. Okay, so remember, number one law, what is that, guys? Triangle law. Have you ever done this in your school already? Triangle law of vector addition. Have you finished, guys, this one?
No, sir.
No, no?
No, sir.
Okay, your school
No,
is still
sir.
your school is still behind, no, I think.
Yes, sir.
Okay, then you guys are advanced. Okay, so see, so what is triangle law of vector addition? Okay, see, I'll explain to you the detail very, very nicely. Please listen nicely. Okay, suppose I want to add this vector. Okay, let's give it a name. I'll take up some time. Okay, I'll do slowly. I'm not in a hurry, you also should not be in a hurry. Okay, this is our vector. I call it a vector. Let's give it a name. Okay, what is this vector, guys? A vector. Okay, I think everybody's clear, right? Yes, everybody's clear with A vector, guys?
Yes, sir.
It has magnitude,
Yes,
yes or
sir.
no? It has some value, right? It has a magnitude, some length it has. Yes.
Yes.
It
Yes, sir.
is pointing in some direction, right? Yes. Okay.
Yes, sir.
Okay. I can also give some tip and tail. Okay, so let me check in SLR what points they are giving. Okay, let's say this point, okay, this point, let's call, for the time being, let's call it O. I could have given any name. This point, let's call it P, okay, for the time being. It doesn't matter actually, but tip and tail. Okay, let me just remove it right now. No need also. Okay, we know this is what? Tip of this vector, this is tail of this vector. Everybody is clear till now? Everybody is happy to see this vector A. Okay, I'll bring another vector, guys. Okay, but let me tell you, this is a similar vector. Okay, similar vector means if the first vector is representing force, then the second vector is also right now force. The B vector is also force. Okay, if the first vector is displacement, the second vector is also what? Displacement. I'll tell you why. Okay, because when I add vectors, right, this is not allowed. No, can you add? Oh, what happened? Why did I leave the meeting? Can you still hear me, guys?
Yes, sir.
Okay, but my screen, no screen. 1 second, huh?
Yes, it's up.
Yeah. I got disconnected. I'm rejoining. 1 second. Don't leave in between, huh? Only if your network is bad, then you can leave. But you have to come back. Okay. So see, I was talking about similar vectors. Okay. Because this is not allowed, right? Can I tell you that I will add force vector with displacement vector? Is it allowed or not allowed?
Not allowed.
Not allowed, sir.
Not allowed. Why? Because how can you add force with whom?
With the vector quantity.
With displacement, right?
Yes, sir. With displacement.
With displacement, both are vectors. This is also vector. What is this?
Vectors of force.
Doesn't make sense. No, 10 newtons added with 5 meters of displacement doesn't make sense at all.
They are different physical units.
Physical units is different. Totally, they are different quantity. They have different dimension or same dimension.
Different dimension.
Dimension also. You cannot add them. No, so this is not allowed. Okay, so that's why I told you. Let's say I want to add which two vectors, guys? A and B.
B.
Okay, and both are different or same vectors or similar vectors. Similar vectors. Okay, not same vectors. I'm just saying similar. Similar means if this is force, the other one is also force. Okay, so B is also a vector. It also has a tip. You can see I'm going to mark it. This is tip of the vector B. This is tail of the vector A. Okay, now
So, but a different direction.
it is a different vector. Yes, example I'll tell you. It's like this is a displacement vector in the east and this is displacement vector in the northeast. No, so both are displacement vectors, but in different directions and different values also. Okay, I can make it big, small, anything you want. Okay, I can do this also. Okay, suppose the question is I want to add these two vectors. That is what we are trying to do. Okay, guys, I'm repeating again. We want to add these two vectors and we are going to use a law called what? Triangle law. So I'm speaking directly about triangle law. Okay, and you check, you will understand it. Okay, so I want to really add them. Okay, so see, when I add these two vectors, let me just show you. If I add vector A with what vector, guys? Vector B. What will I get? I'll get a vector or a scalar?
Vector.
Vectors.
That vector C. Okay, let's not call it C. Let's call it R. The vector R. What will I call it, guys? Resultant vector. Resultant vector. This is clear, I think, no? Right.
Yes, sir.
If I add a vector A with another vector B, then I should get the result of that, right? And that is called what? Nothing but resultant vector. A has magnitude, yes. A has direction. B has magnitude and direction, yes. Our job is to calculate what? Magnitude and direction of the resultant vector. Yes. Are you clear?
Also.
Okay. So A looks like this, right? This is the A vector. B looks like that. Even your resultant vector will look like a vector like this, right? This is your resultant vector, no? Should look like that, right? It's a vector, no? Should like look like an arrow. Okay, so that is what we're investigating. Okay, so look at the rule. Okay, I hope you're getting me what I'm saying. The rule is you take the first vector. See, I'm taking the first vector. You can take any vector as the first vector, by the way. Okay, the B also or A also. The rule is what, guys? You take the first vector. I think you're clear with this. I'm trying to add them. Try to take the first vector. Then you bring the second vector. See, copy, I'm going to paste it, and you join in such a way that the tip of the first vector is touching the tail of the second vector. Can you understand this? Check.
So we join them.
Yeah, you join them. What are you joining with what, guys? Think and tell me.
Vector A with vector B.
But how? Tip of
one vector
Tip of vector A
with the tail of vector B. Okay, but notice something. Did I change the direction of A? No.
No.
It is still pointing. You can check in the same direction, right? Did I change the direction of B?
No.
Sir.
No.
Sir.
It is still pointing the same direction. You can check, right? No change in the direction. Okay, you cannot do this. Okay, you cannot say that no, I'll rotate this and I'll add. No, this is not possible. Okay, you have to keep them different or same direction. Same direction, but just come and join them. Okay, yeah. Okay, you cannot even do this. Okay, you cannot come and make the B vector smaller while joining. Can you understand? Did I change the magnitude or the magnitude is same?
Same.
The magnitude is same. Okay, so now let me tell you. Okay, there's another name. We call it tip tail method. Okay, what is this called?
Tip tail method.
Tip tail method. Okay, that means you're joining the tip and with the tail of the other vector. No, so this is called tip tail method. Okay. Okay, now see. Now where is the resultant vector, right? So let me show you now where is the resultant vector. Okay, by the way, you'll agree, right? I can complete a triangle out of these two, right? If I already have the two sides, I can join and complete a triangle, right? Here, check. Can I join these two and make a complete triangle or not?
Yes, sir.
Yes, sir.
Okay, so that is what I'm going to do. Okay, now you have to be careful. See, try to understand the order here. Okay, see, this is our vector A. I'm just showing you, this is our vector A. Then this is our vector B. Then, okay, look, I'm going in this direction. Okay, I'm not going from the second vector to the first vector back like this. This is not allowed. I'll tell you what do I mean by this. I know you're not getting me. I want to complete this triangle. I'm repeating again. Okay, I want to complete this triangle, but I'll not complete it like this. Okay, I'll not complete like this. A, B, and third side like this. I'm not going to complete like that. That is wrong step. Okay, I'll not complete like that. I'll not go like that, and complete it like that. Okay, see how am I completing it? I'll go in this direction. Yes, that's your A. I'll go in this direction. What is this? B. But the third side, when I use, okay, when I want to complete the third side, I want to bring the third side. I'll bring from here to here. See. So you tell me, did I take the third side of this triangle in the same order or opposite order?
Opposite order.
Okay, those who did not understand, I'll show you again. See, if I go from here to here, that's your A vector, B vector, and if I go like that, this is your what vector? C vector, no? We call it opposite order, same order.
It's the same order.
Same.
We call it same order. Okay, but check how am I going. Okay, I'm taking the first vector, I'm taking the second vector, but when I draw the third vector, right, which is going to complete this triangle, I'm going to take it in which order, guys? Opposite order. Yeah, if I am doing this, okay, if I'm doing this, then this third vector, the third vector, right, this third vector, I am going to call it as the resultant of the vector A and B. Are you clear at least with the resultant?
So what if the second vector is facing in the same direction as the first vector?
Okay, look at him. What is he saying? He's saying is this is the first vector and this is the second vector. This is your question, right?
Yes, sir.
Okay, we will also tackle this problem. Give me some time. Okay, we have answer for this also. Okay, I want to answer with deriving all the formulas and all. Okay, but let me tell you, did you understand what we are going to do, guys?
Yes, sir.
Okay, so tell
Yes,
me.
sir.
So tell me, what is triangle law? What is triangle law of vector addition? So what did you learn? Yes, what is triangle law?
In order to add two vectors.
In order to add two
we have to join
vectors.
the tail of,
Okay.
we have to join the tail of one vector with the tip of the other vector.
Okay. Then
The resultant vector cannot be in the same direction.
that is wrong. That is wrong sentence. Okay, I'll help you out. Okay, but you're trying.
The
So
resultant vector has to be in the opposite order.
okay. Wait. Okay. See, I'll tell you. See, I'll show you the resultant vector here. Then I'll tell you. Okay, you are okay with this, but okay, we have to be very specific. Do you agree? This red arrow represents the resultant, right? As I told you.
Yes, sir.
Yes,
Okay,
sir.
this is a resultant. Okay, so look at the statement. Okay, I'm reading from SL order. Okay, see, what is triangle of vector addition? That's what I'm reading. Okay, if two vectors, look at this, vector A and vector B. I'm writing here. Okay, if two vectors, can you still hear me, guys? Yes, no? Okay.
Yes, sir.
If two vectors can be represented by what? By, okay, two sides of a triangle. Do you agree? Vector A and vector B, right? They are right now being represented by what? Two sides of this triangle. I can name the triangle also if you want. Okay, like let's call it OP and let's call it Q. So what is the triangle, guys? OPQ, no? In this triangle that I have, the two sides, the OP and the side PQ, they are representing our two vectors or not?
Yes, sir.
Okay, the two sides of a triangle, they are
Yes, sir.
representing our two vectors that we want to add, right? Then this rule says, if I can do this, okay, if I can represent the two vectors by these two sides of a triangle, then the third side of this triangle will represent what? Then third side of the triangle, no? Yes or no? But taken in same order or opposite order? Taken in
Opposite.
taken in
Opposite
opposite,
order.
taken in opposite order automatically will represent what? Will represent
Resultant vector.
resultant
Resultant
vector.
vector.
Yes,
Okay.
resultant vector. Yes, okay. I hope you are clear with this.
Yes, sir.
Okay, looking
Yes,
at
sir.
okay, looking at this diagram. Okay, tell me, are you clear? Are you really clear, guys? I'll show you another diagram then. Okay, see, if this is a vector and this is a vector, how do I add them? Tell me. This is vector A, this is vector B. What should I do? Let's take vector B first now. I can take any of them. Okay, so let's take vector B. Okay, so tell me, what do I do, guys? I take the vector A and put it here, right?
So we have to take the vector
Yes.
A
Huh?
and
Take the tail
attach
of
its tail
attach
to the
it.
tip of vector B.
Yes. Okay. Now I will draw the
And
triangle
make a
here.
triangle.
Very good. I'll make a triangle in the same order, opposite order.
So opposite
Opposite.
order.
Opposite.
Check. Do you agree? This purple arrow is showing me the same order or opposite arrow? Check.
Same order.
Same order.
Opposite.
See, the first one goes here, the second one goes here, the third one in the same order will go here, right?
Yes, sir.
Okay. So look at the diagram and tell me now. Am I taking same or opposite order?
So opposite
Opposite
order.
Opposite order. Then yes. Then I'm going to call it resultant of what and what?
Vector B
Resultant
and
of
vector
vector
B.
B and vector A. Okay. Now think and tell me. Okay. What does it look like? Resultant is same as A or bigger in size than A and B?
Bigger in size.
Yes, yes. The resultant looks so long. See, this is the resultant vector. It's much bigger than what and what? Is bigger than A and B.
B and B vector.
Yes, okay. And then you know what? I'll just show you one more idea. Okay, then we can proceed. Okay, I think we can proceed directly. Okay, I'll not give you more ideas right now. Not needed. Okay, I'll go to your this derivation now. Okay, this is important. Let me use this one. Okay, guys, I hope so.
Again, sir.
Which part exactly?
So the triangle law, sir.
Okay, triangle law. Let's read together. Okay, see, Jyotirmoy. Okay, see. Triangle law means what? If two vectors can be represented with what? Two sides of a triangle, right? See, this is a vector A and this is a vector B. I want to add them. If I can represent them by two sides of this triangle, I'm trying to make a complete triangle here. If I can do that, right? Then the rule says the third side taken in the opposite order will automatically represent what? Your resultant vector. That is your triangle law.
Okay, sir.
Okay, just complete a triangle out of these two vectors that you have. Okay, you have two vectors, but try to complete it as a triangle, no? Using those two as a side of a triangle, then the third side will represent your vector, okay, or resultant vector. That is your triangle law, nothing much here, okay? But check now something, and you have to understand this, okay? Now this is our main idea here, okay? This is what we need to do, okay? So yeah, polygon law is also there. I will not speak about that right now, but let's do this one first. See, I'll tell you what is going on, okay? I'm going to take a vector A, just like before. This is my vector A. Let's call it O point and let's call it point P. Okay, everybody's clear with this? I'm going to bring another vector which I told you, right? I'm going to call it as a vector B pointing in some direction. You could have taken B also first, does not matter. I'll show you that also. I'll give you Y and all. This is B. Let's say this point is Q right now, and you will agree with me that this vector, check, this vector, okay, represents what, guys?
Triangle.
This vector represents
Resultant vector.
yes. Okay, everybody is clear with this, okay? So I'm good. I can write like this. See, what is OQ vector? It is what vector? Resultant vector. Okay. Yes. What is OP vector? You know what is OP? A vector.
A vector.
What is PQ vector? Also, this is also clear. What is this? B vector.
B vector.
Okay. Okay. What is A? What is A and what is B? These are points. These are not points. These are vectors, right? A and B are vectors, no? So what is A represent?
Magnitude.
Magnitude of
yes.
OP.
Magnitude of OP.
Yes. Magnitude means length, right? Magnitude means size. Okay. So I can simply write OP and PQ, right?
Yes, sir.
Okay. So what is the what is the magnitude of R? Value of R? Length, right? Not direction, but only length. O Q. Okay, this is clear. You will also agree with me that a vector A when added with vector B, right, according to our law equals to which vector, guys?
R.
R vector, okay.
R.
R vector, yes. I'll tell you what are we investigating here, okay. I want to know, you know what, this thing, say, do I know the value of A vector? Yes.
Yes.
Do I know the value of B vector? Yes.
Yes.
Right? Okay. Do I know the direction of A vector? Yes or no? Check, guys. Yes. Do I know the direction of B vector? Yes. Okay.
Yes.
But
Yes, sir.
our job is this. We don't know what and what, you know, guys. We don't know the magnitude of what.
So
Okay.
magnitude and direction of R.
Magnitude. We want to find out what is the magnitude and what direction of resultant.
Direction.
That is what is known as finding the resultant, right? We want to investigate
Yes, sir.
what is R. We know what is A vector. We know what is B vector. We know the magnitude of A. We know the magnitude of B. We want to know what is the magnitude and direction of resultant of them. So that is what we are going to do right now. It is all about geometry, okay, and think whether you are clear or not. Okay, so I'm going to go back to this diagram. Let's proceed with this. Okay, see, I'm going to draw something now. Okay, check, see, if I draw an arrow which looks here like this, an arrow which looks like this, okay, then the angle between them is this angle. Okay, this is clear, no, guys? Check.
Yes, sir.
Okay, that's the angle between them.
Yes,
Okay,
sir.
and if you remember, we took a vector here like this and vector this light. Okay. Okay, let me just show you something. See, the angle between the vectors is not this. This is not treated as the angle between the vectors. I'll show you, okay, how it is done. Okay, see, what is that? This is called A vector. This is called B vector.
B vector.
So I'll show you how the direction is taken. Okay, please see, guys. Okay, do you agree this is A vector, right? Check.
Yes, sir.
Yes,
Okay,
Yes, sir.
this is the direction of which vector, guys?
B vector.
No, A vector. This is the direction
A
of
vector, sir.
A vector. Okay, let me bring B vector also now. Okay, so this is B vector. You'll agree, right?
Yes, sir.
Okay, so I'm just making dots. Okay, see, this is the direction of which vector? B vector, and this is the direction
B
of A vector, right? Okay, this angle, right, if you notice, it is 90 or more than 90.
So more than
More than 90.
So
Okay,
more than
that angle
90.
I'm not allowed to take. Okay, that angle I'm not allowed to take. What I need to do is this. See, you take this as the direction of what vector? A vector meeting at this point, and this angle obviously makes an angle less than that. This is what we are going to call as angle between A vector and what vector? B vector.
B vector.
Okay, so can you understand?
Yes, sir.
Okay?
Yes, sir.
Because you know what, I could have shifted my vector from here to here, right? And that is how it should look like, see. Okay, so that is the how you talk about angle between them, not like this. This is not the way to talk about angle, right? This is the direction of A, this is the angle between them. Can you understand, guys, what is the meaning of angle between the vectors?
Yes, sir.
Okay,
Yes, sir.
and you know what, depending on this angle, no,
So,
resultant.
like while taking
Yes.
the angle, do we have to put the initial point together?
No, I did not say that. Mike. Okay, I did not say that. Did I say that, guys? Do I have to really put it here? Okay, what he's saying is, do I really have to put this vector there, or it can sit here and still we can find? It can sit there, right? Okay, check. Vishwadeep, check. It can sit there and still I can find the angle or not?
Yes, sir.
Right. It's not compulsory. What he's saying is that do I have to take this vector and put it here, right? No, we don't have to do that. Let it be here only. Tip tail method. Let's keep it there only. But this treat him as an angle, right? This one, right? Okay. Don't bring it there. I'll show you here. See, I'll show you here. Okay, this is A vector. Let me show you the direction of A vector. Okay, this is the direction of A vector. You will be clear, right? This is the direction of what, guys?
A
A vector. Okay, yes. Okay, so that is the direction of A vector, and this is the angle between what?
So A and B vector.
Direction of A vector and direction of B vector. Now it's clear, no? I think.
Yes, sir.
Okay.
Yes, sir.
Yes. So this angle is
Yes,
what
sir.
we are going to call as theta. Okay. So I'm going to write here down. Okay. Tell me what is this angle called? What is theta? Theta to theta, but what is theta actually? Angle between what and what, guys?
A
A
vector.
vector and B vector. Yes. Okay. I think you are clear with theta, right?
Yes, sir.
Yes,
Okay.
sir.
Yes, sir.
Okay, let's check
Yes.
something. Okay, let's check. Very nice. See, what is the angle, guys? Tell me. How much do you think? Large or very small? In this case, right now if the vector is here? Small angle, right? Theta is very
Very
small.
small.
Now theta has become 30 degree, now theta has become 45 degree, now theta has become 60 degree, now theta has become how much? 90 degree. Okay, now theta has become equal to 90, more than 90. More than 90. Yes, more than 90. Now theta has become much more than 90. Now theta has become how much?
180.
180. That means if the vectors are oppositely directed, the angle between them is 180. Opposite 180. Okay. If the vectors are in same direction, what's the angle between them?
0.
0.
0.
Right? Check. If B is here, no, then the angle between them is 0. Right? Same direction, 0. Opposite direction, what's the angle between them? 180
180.
degree. Yes. Okay. What does this mean? Both vectors are what? Right angle, no? At right angle, right?
Yes,
90
sir.
degree. Okay. Right now, let's just keep it here. Don't worry. We can change the angle anytime we want. Any situation we can think about. Okay. Notice something. Do you agree with me that the resultant also will change or not? If the vector is here, if the vector is here, theta is same or changing? Check. Think and tell me. Theta same or changing?
Changing.
Theta, the value of theta is changing. Do you agree with me that the direction and value of or the length of resultant also changes or not?
Yes, sir.
Okay, imagine the vector is here. The length of this resultant will be this one. Oh, sorry. The length of the resultant will be this one, right?
Yes, sir.
Okay, and I was saying something. If the B vector is here, making how much angle, guys? How much angle is B vector is making? 90 degree, no? Then the resultant will be this one. What do you think? Resultant is same or looks shorter now?
So short.
Shorter, yes. Okay, so yeah, what does resultant depends upon? The value of the resultant depends on what? This angle theta or not? Yes. When you change this angle, when the angle between the vectors changes, the size of the resultant changes and direction of the R also changes. Okay, so don't worry, we will get it. It's all geometry now. Okay, check please, guys. Okay, guys, can I say till now is clear? Everybody's clear.
Yes, sir.
Yes,
Okay,
sir.
what about my new students? Right? I forgot to talk to them very quickly. Let me talk to them. Okay, my new students. I remember Esther. No, Esther is still there. Esther, Bajiruhun is also new. No, Bandriti is also new. Bandriti, understanding? Bajiruhun.
Yes, sir.
Okay, Bandriti.
Yes, sir.
Okay, Esther is not talking. Esther is still there. Esther, so sorry. Okay, so many students, no, so I don't get time to talk to all of you. Okay, you can also participate. Okay, girls also can participate when these boys are speaking. No, don't let these boys only answer. Okay. Okay, so see now. Okay, so I'm not saying don't answer to boys. Okay, I'm saying girls also should participate. No, okay, so see. Okay, now see, how do we add? Okay, that is very nice. Okay, see, I will proceed with the construction here. Not Esther, Easter, not Esther, Easter, no? I saw Easter there, okay, that's why I said, okay, fine, okay, so you take time. See, okay, I can do this also, okay, you'll agree with me, I can take the point Q, I'm taking this point, please check, guys, okay, I'm taking this point Q and just dropping a perpendicular. Am I allowed to do this, guys? Check. Construction, that's it.
Yes, sir.
Okay,
Yes,
I'm
sir.
allowed to do this. Okay, when it meets the point N, okay, let's call it point N here. When it meets the direction of a vector, let's just call it point N. This is allowed. Okay, you cannot say no problem at all. We can do that. Okay, now think and tell me. Okay, can I say this is a right angle triangle, guys?
Yes, sir.
Yes, this is a right
Yes,
angle
sir.
triangle. I can say this is also a right angle.
Triangle.
Okay, we can use trigonometry now. Okay, so see, I'm going to use that. Okay, please check nicely. Okay, tell me whether you will agree or not. Okay, what is sine theta?
Perpendicular.
By hypotenuse.
Okay, perpendicular by hypotenuse. Whose hypotenuse here?
So PQ.
PQ.
Oh yes. PQ. Oh sorry, which one is perpendicular here?
QN.
QN.
QN is
QN.
perpendicular by
And PN is
hypotenuse.
the
Who's the hypotenuse?
PQ.
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 Okay, everybody knows sine theta. Yes, I can apply that. Let's apply cos theta also. Okay, what is cos theta,
Base
guys?
by hypotenuse.
Base by
PN by
hypotenuse.
Yeah. So who's the base here?
PN by
PN.
PQ.
By
By PQ.
PQ. Okay, I'm going to just write. Okay, I'll just use sine theta cos theta here. Okay, let's see what do we get from here. Okay, you tell me what is QN from here, and you tell me what is PN from here. Okay, yeah. We've already got it, okay? You just have to tell me. That's it. Qn is how much from this formula? PQ?
PQ sin theta.
PQ sin theta. And what is Pn from here?
PQ cos theta.
PQ cos theta.
PQ cos theta. Okay, let's go back. Okay, look at the diagram and tell me what is Qn represents. Okay, please look. What does Qn represents? This line, right?
So the construction.
Yeah. How long is this line? That is what we have got, right? Yes or no?
Yes, sir.
Okay, so I'm going to show you now. Okay, what does that say? Okay, what is PQ represents here? Who can tell me PQ?
P vector.
PQ represents B vector or only the size of P vector or B vector?
Only the size of
Because see, I don't have this arrow here. Okay, in sine and cos, will you put arrows here like this? No,
No, sir.
that is wrong. No, so right now they are representing vectors or size of vectors.
Size of vectors.
Size of vectors. So I'm going to write B vector or just B.
B sin theta.
B sin theta. Magnitude of Are you guys clear? Please check.
Yes, sir.
Yes,
Yes,
sir.
sir.
PQ, because I wrote earlier also. See, PQ represents magnitude of B vector. OP represents magnitude of A vector. That's what I've done. Okay. Any confusion here, guys? No, I think.
No, sir.
Okay, what is Pn then? Now tell me. Pn is equal to,
B cos theta.
again PQ we have, so we have B and cos
Cos theta.
theta. Now let me show you where is Pn and let me show you where is Qn. Okay, see, Qn is this, so I'm going to write here B sin theta. This is clear for everyone.
Yes, sir.
And Pn is this one, so let me write B cos theta. That's the value of Pn. Okay, so this size, no, from here to here, this is B sin theta, and from here to here it is B cos theta.
So we'll use Pythagoras.
Wait. This is not Pythagoras. This is just trigonometry, right?
Okay, sir.
Okay. So see, in short, let me tell you like this. This is what? Perpendicular or base?
Perpendicular.
And perpendicular is nothing but equal to how much? You know, perpendicular is hypotenuse times sine theta. Okay. What
Yes,
is
sir.
perpendicular, guys? Hypotenuse times sine theta. And what is this? What is this, guys? What is this? Base, no?
Base.
What is base? What is base? Look here. Hypotenuse times
This time.
cos
Perpendicular.
theta. Cos theta. Hypotenuse
Cos theta,
times
yes.
cos theta. Are you clear what I said just now, guys?
Yes, sir.
Yes, sir.
This is what is this, guys? Tell me. This is perpendicular or base?
Perpendicular.
Perpendicular is hypotenuse times
Hypotenuse into sin
sine theta. Hypotenuse times sine theta. Yes. And what is this actually? This is base, right? This whole length.
Yes, sir.
What is base? Base is
Hypotenuse times
cos theta. That's it. That is what I've written actually from all these things that I've done here. Okay, all these things is based on that. I have a note on this. Okay, I've given you. Don't worry. Things are very simple actually. Okay. So till now, don't forget what we have doing or what we are doing. Okay. Don't forget we are looking for what, guys? We are looking for
addition of vectors.
resultant. Magnitude and direction of
Resultant,
resultant. Okay. Now let me ask you a few things. Do I know what is this angle theta or not? Do we know this theta or not? What do you think? Okay.
Yes, sir.
Okay. Think and tell me, guys. Okay.
Yes, sir.
Do I know A vector and B vector or not?
Yes, sir.
We know A vector, B vector. What we don't know is R vector, right? We don't know R vector. Okay. So now think and tell me. Do I know the angle between A vector and B vector or not? Yes, I know the direction of A vector. I know the direction of B vector. That means I know the angle between A and B vector. I think you're clear, no? I think you guys are clear, right?
Yes, sir.
Okay. What we don't know is your R vector, and that is what we're looking for. Okay. So please don't forget this. So I'm asking you again. Tell me, do you know this theta or not?
So we know.
We know theta. Okay. Do we know how big is B vector? Do we know how big is B vector? Yes. Do I know how big is A vector? Yes. Okay.
Yes,
Okay.
sir.
That is what we know. Okay. Now let's start. See, what are we looking for? We are looking for
Resultant.
magnitude. Let's start with magnitude of R. Okay. How to find magnitude of R? It's very simple now. See, magnitude of R vector. Look at the diagram and tell me. Okay. Who represents or what represents magnitude of R vector, guys? Here in my diagram.
A vector plus B vector.
No. Magnitude of R. Size of R. Who represents?
Sir, OQ.
So OP.
OQ. Very good. OQ. OQ, okay, not OQ bar, okay. I'm talking only about magnitude, right?
Yes, sir.
Okay. OQ, okay. Do you agree with me that OQ is a hypotenuse for this big right angle triangle or not?
Yes, sir.
Okay, so I can use Pythagoras theorem now. Okay, so tell me, what is OQ square? Oops.
OP square plus PQ square.
OP
OP square. Wrong. Till
So
here.
ON
Till here.
square plus QN square.
QN square.
Okay, so ON square. You said ON square plus
QN square.
Plus QN square.
QN. Okay, can I apply this? Everybody knows geometry this much. I'm sure you know this. Okay,
Yes,
so I'm
sir.
applying that. Okay. Okay, now let's write down. So I'm going to write OQ square. No problem for me. Okay, what is ON square and QN square? Let me show you here. See. ONN? Yeah. Okay, yeah. Okay, what is ON square? Look at the diagram and tell me. ON represents a length from here to here. Yes or no?
Yes, sir.
Yes, sir.
ON. In place of this, you know what I can write? OP plus PN.
PN.
You'll agree with me? Right, check guys.
Yes,
Yes,
sir.
sir.
Yes, sir.
ON, right, can be written like this. That's it, okay. Plus QN whole thing square. QN, let me show you. QN is here, this one. This one is QN. We have that. So that is very simple, okay. QN is, let me just write QN only for the time being. We already have the value, that is your B sine theta, no? So we
Theta.
can use that, okay. So I'm going to use that, okay. So please check. Now tell me, okay, let's start substituting. In place of OQ, what can I write? Will I write R vector or just I can write R?
So R, because we are finding the magnitude.
Okay, but I can write square, right? That is allowed, no?
Yes, sir.
Yes, sir.
Magnitude of R and squared, okay? Value of R squared, okay, we can do that. What is OP, guys? Look at the diagram, tell me nicely. OQ. OP. Because I'm going to write this now.
A vector.
A vector, it is not A vector, it is magnitude of A plus Pn. What is Pn?
It's a B cos
cos
theta
theta.
B cos theta, yes, whole thing
square.
plus Qn. What is Qn?
B sin theta square.
B sin theta, whole thing square, okay, whole thing square. Qn square means B sin theta square. Okay, at this point, guys, can I say you are clear? Check. It is just geometry, that's it, nothing else.
Yes, sir.
Anybody has doubts, please ask me right now. Anybody has doubts, please ask me right now. Okay, waiting for what?
That R square, sir.
How did I get the R square? Okay, Jyotirmoy, please check. What is OQ here? Jyotirmoy, what is OQ?
Okay, is OP plus PN square.
No. Yeah, what you're saying, I can't understand. Wait. OQ, I'll ask you again, okay? What does OQ represent, Jyotirmoy? OQ.
So R vector.
R vector, okay, but look at this. OQ represents R vector or OQ bar represents R vector?
So OQ bar represents.
Yes. So what does OQ represents? The size of R or not?
Yes, sir.
And what is the meaning of size of R? That means magnitude of R, right? Check.
Yes, sir.
So R represents magnitude, the length, that's it, nothing else, okay? So in place of OQ, when I wrote this formula, right, this is not a vector formula, right? This is coming from what? Pythagoras theorem, no?
Yes, sir.
So in Pythagoras theorem, will I use vectors or without the vectors?
So without.
Without. So that's why I'm using without the vectors, okay? So that's why this is your resultant vector. No, this is the magnitude of resultant vector square. So resultant vector magnitude square. No vector, see. Magnitude, we're all talking about magnitude here, okay? Are you clear? Not Rishikesh, right? Jyotirmoy, are you really clear? Sure.
Yes, sir.
Okay, then I'll proceed. Okay, guys, now we just have to open up this. Okay, so see, it's very simple. I'm going to write here R square equals to, you can help me out. I can write what, guys? Magnitude of the first vector squared plus B square, B square, yes, theta, plus twice
2AB cos theta.
AB cos theta, very good, AB cos theta, plus, what is this? Can I call it B square and sine
B
square theta?
square sin square.
Sin square theta.
Okay, now this is very simple. See, this one and this one. Okay, in your dreams also you can do this one, no? Right. How much?
Yes, sir.
I can write here A square. I can write here.
Plus B square.
Okay, let's write here. Let's write B square. Then let's take common, no? Cos square theta plus
Sin square theta.
for the B square. Okay, because here also we have B square. Here also we have B square, no? So plus twice AB cos theta. Okay, so many things are happening. Okay, so A is equal to how much now? R square equal to A square plus
A square plus B square.
this is how much? 1, right?
Yes, sir.
Yes, sir.
Okay, you know this one. Okay, sine square theta plus cos square theta is 1. So b square plus
So basically,
twice a b and cos
cos theta.
theta. Now the final step, look at this. Okay, then root over, right? Because the square can be taken on the other side, no? On the other side, the square will become square root. I think you know this one, right? I can
Yes,
take
sir.
I can take this square on the other side and it can become what, guys? Square root.
Square.
So
A
what will I
square.
get? A square plus b square plus twice ab cos theta. The final thing I want to speak is this. Okay, this is not yet over. Okay, guys, but listen. Okay, very nicely, very easy idea. See, let's be clear. What is this?
Resultant magnitude.
Magnitude of resultant.
Magnitude of resultant. Very good. Magnitude of resultant. Everybody's happy with this. Okay, size of the resultant. Okay, what is a? What is this here? Resultant of what?
A and B.
A and B. A and B are two vectors, and A has a size of A, of course, and B represents here magnitude. Okay, these are magnitudes. Okay, plus twice AB, magnitude of A, magnitude of B, cosine of the angle between them. Okay, this is how you need to use it. Okay, I'm going to show you very quickly one example. Okay, please check. See. Okay, example is this. See, this is a displacement vector. This is a displacement vector. Okay, just an example. This is 2 meters. Just an example. Okay, 2 meters. Let's say this is 3 meters. Just an example again. Okay, can you understand, guys, what I'm saying? How many vectors we have? Two vectors.
So 2 vectors.
What is the magnitude of the first displacement vector? 2 meters.
2 meters.
What is the magnitude of the second displacement vector?
3 meters.
What's the angle between them?
So 60 degree.
You will all agree that I can take the third side opposite in order, right, to complete a triangle.
Yes, sir.
This is your resultant, right? Resultant. Now I'm going to tell you how long it is. Okay, see, I can tell you how long it is, because you know what, I know how long is the magnitude of A vector, B vector, and I know the angle between them, no? So I should be able to tell you
Yes.
how long is R vector. Okay, so now tell me what to write, guys. Tell me. Root over of
A square.
A square. What is A here? A means 2 meter, right?
2 meters.
Square plus
3
3
square.
square plus twice A
Into 2 into 3.
into 3, and cosine cos of what?
Cos
Cos of
60.
60 degree.
Cos 60 degree. Okay, so when I solve this, I don't know. Okay, right now it's very lengthy. I don't want to solve it, but I'm going to get a number. Okay, what do you think? I'll go at equal to 2, equal to 3, or more than 2 and 3? Like right now, looks like what?
More than
More than
Root over 90.
more than 3 meters. Okay, but you really got the answer. How much you said?
Root over 90.
Root over 19. Very good. If it is correct. Okay, I don't know. Okay, let's just believe him. Okay, Vishwadeep is good
Yes,
in maths.
sir.
Okay, let's believe him. Okay. Okay, wait a minute. Listen now. See. So what have I got using this formula, guys?
Magnitude of resultant.
Magnitude of resultant. Okay, now let me ask you. Okay, let me ask you this question. Do you realize it is not so easy like adding scalars, right?
Yes, sir.
Yes, sir.
Yes or no?
Yes,
I'm
sir.
talking to all of you. Okay, all of you. Only some are responding. Okay, right now you should respond. Okay, I'm talking to all of you guys. Okay, do you realize it is not so simple? Okay, you have to take care of so many things, not to add vectors. Okay, and then this is what you should do.
So the formula is for every numericals we'll do.
Every numericals, very good. Yes, it is a formula for general formula for any two vectors which are so and so angle, right, between them, which have so much so angle between them. You are going to use only this formula. There's no other formula. This one only.
Okay, so but only for triangular law.
Even for parallelogram law, there's another law. Same formula. See,
Okay,
we are trying to add vectors using triangle law, parallelogram law, polygon law, right? Do you think we'll get different answers or same answers? There are different laws, but the answer should be what?
Same.
Same. We are trying to add vectors, but using different law, no? We'll get same answer. Okay, we'll not get different answer. Okay, guys, at this point, are you clear? I think I've taken too much time. Okay, to reach till here. Okay, but I think you understood what I did just now.
Yes, sir.
Not yet over.
Yes, sir.
Not yet over. Not yet over. Okay. Okay. So. Okay, we will use it up. Don't worry. Every time we can do that. Okay. Now I need to ask you: did I really find what I wanted to find?
No, sir, direction.
No, sir.
What is
Direction
what is not?
Direction.
just find the magnitude of resultant.
But what about the direction?
Direction.
Direction of resultant. How will I talk about direction of resultant? There is no x-axis here, there is no y-axis here. Okay, so I have to talk direction of resultant. You know what? By looking at the direction of a vector and which vector?
B vector.
B vector.
Okay, I'm repeating again. Okay, there is no x-axis here, y-axis. Okay, it becomes difficult to tell you the direction. Okay, but look, there's a very nice method. Okay, check. Do you agree that I can label this angle as phi? Can I do that? Phi? Can I call it phi, guys?
Yes, sir.
All of you clear, right? I can call that angle as phi, no? Between angle between what and what, guys? One of the vector A and which vector? And not B, okay? R vector. This
So
phi
what
is
does phi symbolize?
phi is representing just an angle, just like theta, right? Theta, and this is phi. Different. This is an angle between what and what? A and B vector, right?
Yes, sir.
A and B vector. What is phi? It's an angle between what and what, guys?
A
R
vector
vector
and R
and
vector.
A vector and R vector. Yes, exactly that. Okay, so now think and tell me. Okay, if I somehow tell you that phi is 30 degree, do I know the direction of R vector or not?
Yes.
Yes, sir.
Yes, sir.
Okay, what does it mean? It means that the resultant vector makes how much angle, guys?
30 degree.
30 degree
30
with respect to which vector?
A vector.
A vector.
And I told you at the beginning, right? We already know the direction of A vector, and somebody comes and tells you that the resultant is 30 degree from A vector. That means I know the resultant vector direction also, right?
Yes, sir.
Okay,
Yes,
so you know what? I just have to now show you how to calculate this phi. That's it. Is it clear, guys? Are you clear?
Yes.
Okay, so what we are going to do now? We are going to calculate phi.
Phi.
Calculating phi means knowing the direction of R vector. Yes, Provina also. Okay, she understood. Okay, so I think I can proceed. Okay, so sorry. Okay, guys, I'm not calling all of your names right now. I cannot. Okay, because too many students right now. Okay, so Machi Bazar has become no. Other teachers, how are they doing online? So many at the time.
Yes, but
So we finish with unit 2.
No, I'm talking about how many students online.
52
52.
in our class.
52.
Yes, sir.
No, different.
35, 36.
Other tuition I'm talking about. Other tuition online.
Yes, like 35, 36.
35, 36 only, no?
It's usually 19 to 20 in our tuition.
19 to 20. Only this one has become 35. Okay, I don't want to take two batch. Okay, I don't think so. That's going to help you. Okay, it's more energy loss for me only, no? Oh yeah, one more thing. Okay, before I calculate that phi. Okay, what do you suggest? Do you want to start? Some of you want to start online? Oh, sorry, offline.
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
Okay.
sir.
Who does not want?
Sir, me.
Who is me here?
Sir, Giovanna.
Giovanna doesn't want. Giovanna is happy with this. Then
Sir,
I'm
me.
also happy with online.
Giovanna, I want online. Manbha also wants online. Manbha, yes. Yeah, tell me your name. You can tell me. Online. Biswatama is okay. Online, okay. Online is fine. See, these people all are online is fine. See, you guys
Say
are
just
using.
stream for them in online.
No, that the quality will not be nice, right? Online. Okay, we'll have this voting later. Okay. No, I can do like this. Okay, those who want come offline also. I can make a group for that separately. Okay,
Okay, sir.
and those who want to come
Yes,
and clear
sir.
their doubts offline, they can come. Okay, so I think we can have that. But we are not going to do this. Okay, we are not going to have a very big group. So those who want, not forcing, those who want to continue online, they will continue. Okay, we'll talk about that later. Okay, let's complete this one. See, guys. Okay. Okay, how I will calculate phi, I'll show you. Okay, see, let me just copy this diagram right now. Already a mess here. Just give me some time, guys. Okay, copy, paste. I am looking for phi. Don't forget, I'm looking for phi. Okay, how to calculate? See, okay, think and tell me whether you're clear or not. Okay, check. I want to write 10, you know, obviously 10 phi. I want to write that. Okay, so help me out, guys. What is 10 phi according to this diagram?
perpendicular by base.
Okay, who's the perpendicular, guys?
Qn.
Qn, very good. Qn
QN, sir.
Qn
by
by
base.
On.
By
By
ON.
ON, yes, that's the base. Okay, now let's continue. Okay, what is 10 phi again from here? What is Qn? The value of Qn? B
B sin
B
theta.
sin theta,
B
yes.
sin
And
theta.
what is ON? ON is again from here to here, right?
OP plus PN.
Okay.
cos theta
So,
plus A.
So
OP
A
plus
plus, not A vector,
Plus
not A
B
vector.
cos
A plus
A plus B cos theta.
B cos theta. Yes.
Theta.
Okay. Now don't forget, what are we looking for? We're looking for tan phi or just phi?
direction.
We're looking
So,
for, okay, so
10 phi.
tan phi or we're looking for phi?
Phi.
Phi, sir.
Okay, how to get phi from here? Let me show you. Okay, I can use tan inverse on both sides, no? Tan inverse tan phi equals to tan inverse B sin theta by A plus B cos theta.
B cos theta.
Okay, did you understand, guys, what I did just now? Check.
Yes, sir.
I have used tan phi on both sides. We can do this. I think you know, right?
Yes, sir.
Okay, if I use
Yes,
tan
sir.
inverse, okay, tan inverse I can use on both sides. Now what does this tan inverse do on the left hand side? It removes the tan, right? Inverse of tan means what? Go and remove. This inverse is like anti-tan, no? Anti, okay, anti.
Yes,
It
sir.
goes and removes that tan. What will I get, guys, here?
Phi
Phi equals to
10 to the power minus 1. B
not
sin-
10 to the power minus 1. We have to call it tan inverse, okay?
Verse.
Yes, sir.
Okay. You want to call it 10 to the power minus 1? No, that's a bad idea thing, okay? Don't do that, okay? So B what?
B sin theta
B sin
by
theta by
A plus B
A
cos
plus B cos theta. Now let me ask you, did we really get the direction or not? Let's check, okay? Do I know what is B? Yes. I know
Yes,
how
sir.
big is the
Yes,
second
sir.
vector. I know how much is the magnitude of the first vector. I know the angle between them. So obviously, I just have to plug in this in the calculator, okay? I'll give you an example. Suppose phi comes out to be equal to tan inverse of 1. What does it mean, guys? Okay, by the way, do you know the meaning of tan inverse? What does it mean?
No, sir.
No. Okay. See, if I am writing tan inverse of 1, it means I'm asking you, okay, for what angle tan becomes equal to 1? I'm asking you angle.
45 degree.
45
45.
And that is what is called phi, no? That is why we are calling it phi. Can you understand the meaning of tan inverse? That is true for sine inverse also, okay? Sine inverse of half. I'm asking you for what angle sine becomes half?
30.
30 degrees. So see this one. Now it's clear, no? I think, guys, now it's clear.
Yes, sir.
Here also I'm doing the same thing or not? Check. Tan inverse of 1. You know, you have told me 45 degree. Here check. Tan inverse of some value, right?
Yes, sir.
This value may be what? This value may become half. This value may become 1. This may value anything, right? It corresponds to some angle or not? To correspond to tan function, right?
Yes.
Some angle it is. So don't worry, we can get it, okay? So but at this point, can I say, did you really understand what I did?
Yes, sir.
Okay. Then I will take a break. But in that break, I'll show you that you have to do this question here. Okay, 1 second. Let me find out. Okay, you can do so many of them also. See, you will also draw the diagram. Okay. Okay, I'm going to give you right now. Okay. Let me take the photo. Right? Where is it? Home. Here. Insert. Camera. Accelerator. Don't open accelerator and check the solution. Okay. That is not what you should do. I'll quickly take the photo. Don't look at the solution. Please draw the diagram, okay? This is your first question. I'll give you more. You can
So,
start. Yes,
can
yes.
you show the formula for that R equals?
Okay, I will write the formula. Okay, the formula for resultant, if you want to find the resultant, is equal to what, guys? Root over of? Tell me, guys.
A square plus B
A
square.
square plus B square plus twice
AB
AB
AB cos
cos
theta.
theta. Okay.
Yeah.
What about tan phi? Or let's say phi, no? Phi. I'll talk about phi, okay, if you are not so clear.
So tan inverse
Tan inverse, very good.
into
Yes. Inside, what should I write? B
so
B sin theta by A
theta
plus
plus B cos theta.
B cos theta. Cos theta. Okay, you need to tell me something. What is phi if I write like that? Angle between what and what?
Angle between the two vectors.
Resultant vector and the A vector. A vector.
Resultant vector and A
A
vector.
vector.
Resultant vector and A vector. You cannot say two vectors like that. Okay, you have to say resultant vector and A vector. If I write like that, okay. And you know what? If I write the other way around, just imagine, okay. It will be what? If I write the other way around, that means, okay, we'll talk about that later, other way around thing. And okay, you do this one first, start this one.
So the forces are acting on the same direction, right?
Use triangle law, that's what I want to tell you, because these are two vectors, no?
Yes, sir.
This is a vector, this is a vector, this is also what? Vector. I want to get the resultant, right? So you have option with you. You can use triangle law, you can use parallelogram law, you can use any other law that you know. Okay, so I am saying use triangle law, no? So draw the diagram accordingly. Okay, so start, guys, this one. After this I'll give you another one. Okay, yeah, I'll not give you the next one right now. Let you start. Yes, root over 109. That's what he got. Let's be clear. Okay, what is A, guys, for you here? A 5 newtons. B is a magnitude of the second vector, 7 newtons. Theta is very simple.
I got root over 109.
109. Okay, so answer is R is okay. Is equal to how much, guys? Root over of
109.
109. Okay, 109, and that is, you know how much? 10.44. Okay. You have to
So
use
we can
calculators.
just stop in the root over 109.
Yes, but if you have calculator, MBOS have calculators, use this. CBSE don't have. I don't know what to say to you. Okay, but those who have, use calculator for the time being. No, later we'll see exam time what happens.
Yes,
Okay,
sir.
so this one we have. Okay, wait a minute. But what is the question? You know, find the resultant. What is the meaning of find the resultant? When they ask you find the resultant force, it does not only mean magnitude.
Yes, or direction
You also have to tell me-
We'll use the phi.
Direction. So I'm asking you, did you really draw the direction? Sorry, diagram or not, guys? What is this? A, no?
Yes,
This is
sir.
A,
I just put
and this is what? B.
B.
This is 5 newtons. This is 7
7
newtons.
Newton.
And this angle, if you remember, this angle is given, right? What is this? Theta.
60 degree.
60 degree. Okay, so I'm looking for phi right now. Yes or no? This phi, right?
Yes, sir.
There's a result, and this is phi. Okay, so how we'll calculate phi? Now please tell me that also. I'm
Tan
waiting.
inverse.
Waiting. Okay, tan inverse.
B sine theta.
Calculate.
So,
I'm going off now. My calculate and tell me the
Okay,
answer.
sir.
Hello, Dipanjali, you joined. Hello, Dipanjali. You joined just now, Dipanjali. Hello, Dipanjali, can you hear me?
So I joined before.
Oh, you joined before, no? Okay.
Yes.
Okay.
So Rohan,
Yes, Manpa, yes.
so is this today's last topic?
You're tired. What happened?
No, sir, because the after tomorrow I'll be having test semester, so tomorrow I have 2 tuitions, so I have to study.
Okay. You do like that. You can leave. Okay. But till now you understood what I was doing.
So,
Okay, then you can leave. Okay, no problem.
nothing new. You do.
I will not do anything. I'll not do anything new. I'll just discuss maybe only one problem. Maybe I'll discuss. After this, I'll stop. Okay. Next day we will do a lot of things. Okay.
Okay. Sir.
Okay.
Okay. So good night.
Okay.
Sir.
Good night. Any answers, guys? Tan inverse, or let's say the value of phi. Any answers, guys? Waiting. Tan inverse.
So into 0.7131.
0.7131. Okay, fine. I'll keep it till here. 31. I'll tell you what to do with this. Okay, those who don't know what to do with this. Okay.
Yes, sir.
7√3/17.
Yes,
I
sir.
want in decimals like this. If you can tell me, not with roots. Okay, I want you to tell me answer like this. Use calculator. Use calculator. No. Don't tell me. Don't tell me with roots. Without roots, you're fine. You got till here. It's fine. I don't want roots. I want the answer like that. Okay. Anybody else who got this one? Please tell me. Confirm. If you're really doing.
Yes, sir.
Don't be lazy. Don't be lazy. Yes, guys.
0.7132.
Okay, fine. I'll show you. Okay, if you are confused what to do next with this, no, I'll show you that. Okay, so that is important. Guys, can I ask you that it is clear for all of you? Girls.
Yes.
Yes, sir.
Okay, then I will show you what to do with this. Okay, let me open.
0.71317.
0. Wait. Okay.
71317.
Yes. Okay, you should get like that. Okay, then I'll show you. Okay, how to solve that part. Calculator. Let me open calculator. Okay, look here, guys. How what to do? Okay. Where is that other one? Yeah. This is just normal, no? Inverse is also there. Okay. So what is that, guys? Tan inverse, no? Not working. Here. Tan inverse. See, guys. Can you see tan inverse? I don't know how will you use your calculator. Okay. But I'm going to click on inverse, and this is a tan inverse. So it is called arc10. Okay, in some calculators. Then tell me the value, guys. What is the value inside?
0.7131.
Okay, let me write 0.7131. Okay, I'm going to press equal now. Okay, let's check what do we get. See, we got how much. Okay, this is in degrees. I want. Okay, this one is in degrees. So what is the degree, guys? Check how many degree? 35.49.
49.
Okay,
26.
those who did not understand the step, I'll do again. Okay, see AC, right? See, what should I write, guys? I should write inverse, tan inverse, that is arc10 in some calculators. Some they write tan inverse only. Then I'll put the number what I got inside. Okay, 0.0. No. I got. Where's the delete button now here? Where's the delete button? Can you find a delete button here? No. Okay. Oh yeah, that one. So 0.7131, no, something like that, right? Then I'm just going to press equal to sign. Okay, this is what you're going to get. See, guys, in your calculator you're going to do it. Okay, so 35.49, no, so that is what I'm going to use. Okay, so see, the value of this in your calculator comes out to be 30. I forgot the angle again. 35.49 degrees. Okay, so that is what I'm going to write like that. Are you clear with how to write angle, guys? That means we have found out this angle. See this one.
So how to convert into degrees?
How to convert into degrees? Okay, wait a minute. Are you really getting it? Okay, wait a minute. Do you really have calculator or not? First tell me. Means are you using it right now?
No, sir.
No.
No, sir.
You have to use, okay, for this
sir.
right now you have to use, because this is not a standard value, okay. If the phi comes out to be tan inverse of how much? 1.732. That means root, no? I think root 3, no?
Yes.
Yes, sir.
Okay, so tan inverse of root 3. Tell me how much is it, guys? Which angle? We get root 3? 60 degree, no?
Yes, sir.
Okay. Tan of 60 degrees how much?
Root 3.
Root 3, no? So if the numbers are like that, then you can directly, no need calculator. Sometimes your school will ask you in such a way that you will get this number and the answer is directly how many degrees? 60 degree. But
So,
today, yes.
So in the exam, can we just write in
Very
time
good,
inverse?
very good question. Okay, can we in the exam time, can I just do this? Because sometimes CBSE will not allow you. So can I write only this much? Yes, you are allowed to write only this much. If you are not allowed to carry calculator, you can put here also and give the answer. For CBSE, I'm talking, okay. I think this is fine. I think you understood what we did here, no? I think it's clear, guys. All of you, can I say it's clear?
Yes, sir.
Yes, sir.
Anyone who did not understand what we did? Anyone who has confusion? Okay, so you are quiet, no confusion. Okay, fine. I'll do like this. Please check the notes. Please go through only one thing today, that is your triangle law of vector addition. Next day parallelogram law we'll do. It's very simple. It's exactly a copy of this only. It's going to be very simple, don't worry. Formula, we are going to not get anything different, same formula. I'm done for today, okay. Next day after some time I will send you some questions. Please solve that question, okay. So that's it, okay, for today, so thank you class. Bye
Sir.
Bye, sir.
bye.
So can send the notes.
Bye, sir.
I've already sent the notes in the group.
Okay, sir.
Okay,
Can you
please.
explain gravitation, sir?
Oh, gravitation. What about gravitation? How much they have finished, Jyotima, in your school?
So they are done with universal law of gravitation.
Only that much?
So till then,
Sir, I didn't receive the notes.
Okay. Please check though. Who can send? I think Jyotima can send you. Okay. Jyotima, please send him.
okay, sir. So which one?
This vectors. Vectors is there. Me too. Who said me too? This one? I could not recall. Prayas. No. Okay. So please check.
Send who, sir?
You have to send to in the group. You send. They will collect from there.
Okay, sir.
Vectors, Vectors ka.
Excuse me, sir.
Yes, somebody. Yes. Abhijit.
Can you send me the recording for this lecture, because some parts I couldn't, attend because I had to go somewhere. It was very important.
Okay, fine. I'll do that.
Sir, can I please have the
sir,
recording too?
Yes. Okay. I did not delete the previous one, but I will delete. Okay. Very soon. When are you going to watch, guys?
Sir, which one?
This one. Today's one. Tomorrow you're going to watch.
Sir, tomorrow.
Okay. Then tomorrow evening I'll delete. Okay.
Sir,
Yes.
don't remove, sir. For exam, it will be helpful for
No,
us.
you don't understand. If I keep on uploading the videos, no,
Sir,
you
keep
guys
it in
will.
your PC.
Yes, sir.
I'll keep in my
Sir,
PC.
keep it private.
Okay.
Google Drive.
I can do that. But one more thing, no, if I keep uploading here, no, you'll do like this. Okay, leave the tuition and okay, just watch the video, no. So my loss, no, like that.
So just keep the video.
Yes, I'll
private,
keep. I'll
and
keep.
when we require.
Yes. Okay. Bye. Okay, I'll do that,
Sir,